Hey everybody, my name's Steve. I'm a principal engineer in big tech and an open source contributor and enthusiast, and this is Linux, by the way. If you've ever wanted to run a Minecraft server that you and your friends could log into and that keeps running even when your computer's off, Linux is a great way to do that. I'm going to show you step by step how to set up Ubuntu and put Minecraft on there and run a server and configure it in what's called a Docker container. Before we get started, make sure to hit the like and subscribe button. It really helps the channel out. And also, I posted some links below for products such as Fastmail, which is where I host my email personally, and it gives me credit for that. And it's a great way to say thanks if you like the content. The first thing we need to do is find a computer. The good news is that if you have older hardware laying around, it probably will work for this. Linux runs on a wide variety of hardware, and it's very efficient. Minecraft is built on Java, which is meant to run on servers and is also fairly optimized. What we're looking for is mostly 8 gigs of RAM. I've set up Minecraft servers with 3 or 4 gigs of RAM, and it tends to crash when people log on. And so 8 gigs is a good, safe buffer that allows you to have you and your friends on and not have to worry about micromanaging the server or constantly restarting it. But the CPU power is really minimal in terms of requirements. I've ran it on very old computers and not had any problems with the actual processor performance. The first thing we're going to do is set up a virtual machine. This just means that I have a real computer running and I'm taking part of it to run Minecraft. It's going to look and feel just like a real computer, and you can follow these same steps on your real computer if you don't have a virtual machine. In this case, I'm using Proxmox, which is basically an open source VMware, and it allows me to manage all of this right through my web console, so I don't have to do too many commands or anything, and I can see things like the memory usage and the processor usage, and it's pretty user-friendly. I recommend you check it out if you are wanting to run a virtual machine. So the first thing we're going to do is click Create Virtual Machine, and then we're going to give it a name. In this case, we can just call it Minecraft. And for OS, we're going to pick an ISO image. If you haven't done this before, for the server version, I recommend going with Ubuntu 22.04. It's not the newest release, but it's very stable. It works great with Minecraft, and we won't have any issues from the operating system side running it, which is really important. There's also a desktop version and a server version. Most of the steps I'm going to show you today will work on either one. So if you did have a computer that was also your desktop, you could still run a Minecraft server there, no problem. We're going to pick the server version today to run in the virtual machine. In Proxmox, it lets us upload an ISO image, and so I've uploaded Ubuntu 22.04 here, and I'm going to select that, and I'm going to click Next. And then for the settings here, you can generally just leave these the default. And for the disk size, it's saying a default of 32 gigs. So for the machine I have set up, I have a lot of disk space and a lot of CPUs and memory. You don't have to give it all of this space or anything else. So if you're in a constrained environment, definitely turn this down. I'm going to pick VM1 storage, and I've set the disk space to 100 gigabytes. You can probably get away with even 10 gigabytes if you need to. I'm just going with this because I have the space. We're going to go ahead and click Next. For cores, I'm going to go ahead and set it to 8 here because I have a lot of cores available. If you have less, that's fine. Minecraft will run great even on 2 cores with, 8 to 10 players, so don't worry too much about that. For memory, if you can swing it, I definitely recommend going with 8 gigabytes of memory. I've seen servers crash with even 2 players, depending on the scenario, with big structures and lots of TNT and dynamic interactions happening. So 8 gigabytes gives us enough headroom that we don't have to worry about the server crashing. For networking, it's very important that we get this right, or we won't be able to connect to our server. In this case, I'm picking a bridged interface. What that means is I have a server and we've made a virtual machine, and they're going to share the same network card. So our network bridge will be the same as the server's card, and that will allow us to take connections into our Minecraft server. If you see something else here, or if you're using a different software, make sure that you can access your machine by the network, because that's how we'll be connecting to it from the Minecraft game clients. QEMU is actually what allows us to run the virtual machines. On Linux, it typically interacts with something called KVM, which is not the same thing that switches between monitors and keyboards and stuff. It's actually a Linux kernel feature. Now that we have the Minecraft virtual machine set up, we can go ahead and tell it to start. And so we'll click that. On the left-hand side, we can see that now it's running. We can see it has 8 CPUs, 8 gigs of memory, 100 gigs of disk. If I click on console, I can see this exactly as if I had a keyboard monitor hooked up. Although in this case, it's a virtual machine. It's not a real computer. It's just inside of a real computer. So let's go ahead and click install. So once it's done booting up, you'll be greeted with a black screen with an orange bar, and that means that we're good to get started. We're going to go ahead and pick our language, which is English, and we're going to update to the new installer. This screen is just asking us if we have a keyboard of a different language. We can go ahead and set that up here. In this case, we're using US English, so we can click done. And we're going to install Ubuntu server, so you can just keep that as is too. If you do have odd hardware or something goes wrong, you can tell it to search for third-party drivers. Because we're running in a virtual machine, that shouldn't be an issue, so we're going to go ahead and not check that box. And we'll click done. You'll see here, if bridge network is working, you'll have an IP address. So if we check out this ENS18, that's our network adapter, and it's virtual, and it has an IP address already, which is 10.0.0.196. If you don't have an IP address or it can't figure it out, you may need to check your network settings so that it can get an IP address, because that's how we're going to connect to it. So we'll click done here. We don't need a proxy. Some people need a proxy to get to the internet. Most connections in the residential United States don't, but if you do, you can put that information in here. It's now going to check all of the mirrors, which are where we download updates and packages for Linux, and it's going to try and figure out which one is fastest. So it says we've passed our test, and we're going to download from us.archive.ubuntu.com, which makes sense because that's where we are. And we'll click next there, and we will tell it to use the entire disk, and we'll set this up as an LVM group. LVM is a logical volume manager, and what that allows us to do is make different volumes on Linux so that we could have like our log files go to a volume, have the user directories go to another volume, and have our programs go to another volume, so that if you filled up your logs, for instance, the other volumes might still have space. In this case, we won't really need to worry about that much. On Minecraft, we're just going to write to a single data directory, but it's nice to have LVM in case your needs grow or change over time, because it allows you to have future flexibility. I'm going to go ahead and also encrypt this disk with Lux. This is just handy because if you end up trying to delete the server or sell it or whatever, you don't want your data and your passwords sitting on there. And so it's a lot better to keep it encrypted. So I'm going to go ahead and do a passphrase of Linux, by the way. Linux, by the way. Also, if you do set a passphrase, every time it reboots, you're going to need to enter that. So it could cause an issue if your machine is constantly resetting and you're not there at the keyboard, or if you're away and you're not at the data center, you won't be able to enter the password that way. So keep that in mind. This is the file system summary screen. So by default, Ubuntu has allocated 49 gigabytes to our root partition, which is where all our files will go, and 2 gigabytes to the boot partition. And that will be an initial RAM disk there that we're going to boot into that loads the system, and we'll have maybe some backup files there in case we have a bad upgrade. In this case, one thing to note too is that the actual volume group has 98 gigabytes. It's only given 48 to the root partition. So we don't really need that space. It's just extra space. But if you want it all available so that it's just there, what you can do is you can go down and go to Ubuntu LV and click edit, and then you can change this number. So we're getting a max of 97.980. So we can do 97.980 here, and then click save. And then that way we will have used all the space on our device. The trade-offs is that if you have a device and you have extra room, you could later on increase that size if you needed it, or allocate it somewhere else. Whereas this way, we're just saying, just use all the space up front. So if we run out of space, we'd be in trouble because we have no more space to give in any case. We'll click done here, and this says this is a destructive operation. So if you're newer to computers, or if this is happening on your desktop or somewhere with important data, make sure you're not going to delete things. This configuration that I showed you is definitely going to delete everything on this disk, and it may do the same for you. So only click continue here if you're sure that there's nothing that you're worried about deleting or anything odd happened or anything. We're going to click continue. And so this is a username. In this case, we're going to do Linux, by the way, and our server name is going to be Minecraft. You can pick whatever username and server name you'd like. We're going to say Linux, by the way. Pick a strong password so that people don't guess it. The next screen also offers to sign us up for Ubuntu Pro. Ubuntu Pro is a feature that allows you to get some additional software patches and longer updates It's not really needed. We'll probably upgrade to the next version of Ubuntu before that comes into play. So I would go ahead and skip that. The next screen is SSH configuration. I recommend that you enable SSH access because the Proxmox console can be a little slower than SSH, and also SSH is very convenient, especially if you're accessing the computer remotely or if you're traveling and you don't always have your Proxmox access handy. So we'll go ahead and click install OpenSSH server and click done there. In terms of packages we really only need Docker. Docker is going to allow us to put Minecraft and Java all in a container, and then we're going to manage that container. That allows us to download a pre-built image and not have to worry about configuring the Java JVM and various configuration files and paths. It's going to be just ready to go. And also, if we need to migrate it to a new server later, we can do that a lot easier because we picked a container. So go ahead and click Docker here and click done. And as you can see, the install is going forward. It's installing OpenSSH. It's configured our disks, and this will probably take about 5 minutes or so. And so I'll fast forward this and catch up with you in a minute. Quick note, if you're using Proxmox, you can also check out the summary tab, and that will allow you to see what your computer's doing. And so in this case, we're actually using 5.27 gigabytes of RAM already. So it was good we gave it 8. And the CPU is doing pretty good. It's not using a ton right here, and we did go up to 45% earlier. And you can also see here where it's downloading network updates, which are just the security patches for the installer. And then it's doing a bunch of writes to disk. So this is really handy if you want to know, like, is the server doing anything, or what's taking most of the time and resources. Is these graphs are really handy for that. At this point in the install is actually complete. And what it's doing now is it's downloading security updates. So we'll just let that go for a second and finish so that we have the most up-to-date system for the rest of the tutorial. That was pretty quick on this computer. Your experience may vary, but on this one, it was fast. We're gonna go ahead and reboot the machine now and check it out. And so you can see here, because we picked encryption, when it boots up, I do have to go in the console and type our encryption password here. So I'm gonna go ahead and type that in, and that should let it continue booting. Now the system's ready to log in. So we're going to go ahead and type Linux, by the way, and these were to set up the installer. And the most important part about this is that you check out your IP address. So here's my IP address, which is 10.0.0.196. I'm going to write that down because that's how I'm going to connect to this system from my network. It's not accessible from the internet. It's only accessible from my local network. The next thing we can do is we can SSH into our virtual server and start configuring it rather than using the console. It's just a little faster, it supports cut and paste better. There's a lot of reasons to use SSH. If you're on Windows, you can download a tool like Putty. It looks super old school, but it works great, easy to use. And you could also use the Windows subsystem for Linux to connect to. And if you're on Mac OS, it ships with the terminal and it should have SSH already. In this case, we're running Pop! OS from System 76. And so we can go ahead and SSH into it. And we're going to say Linux, by the way, at the IP address that we wrote down, which in this case is 10.0.0.196. It's going to ask us if we know this host. So if this is your first time connecting, you've probably never seen this before, you can click yes here and then type your password in. And we're in. So SSH is one of the primary ways that computer administrators connect to servers and run commands. Now that we're logged in the system, we want to run Docker. So if we do a Docker PS, we're going to see that we have permission denied. And that's because by default, our user can't administrate Docker. And so if we check out the permissions on that, we can do a ls-la, which means list all of the attributes. And we see here it's owned by root and root. So what we're going to do is we're going to become the administrator of the system. And we're going to do that first by typing groups. And these are all the permissions we have as a group of users. And we have a sudo permission. So in this case, we can type sudo-i, and now we're the administrator of the system. If you've ever been on Windows and tried to install something and it says, are you sure you want to continue this action? We basically did the same thing. We're now the administrator of the system. The first thing is root we're going to do is we're going to do add group, and we're going to type Docker, and that's going to make a new Docker group. Now that we have the Docker group, we need to make sure it can access the Docker socket. So we'll do an ls-la again on var run docker.socket. You can also use tab to autocomplete that, so you don't have to type the whole thing. So if you're confused or if you're lost in the file system, sometimes hitting tab will help you out there. And now we're going to do a ch group. We're going to type Docker, and we're just going to click this and middle click to paste it in. And then we'll run the ls-la, and I'm just hitting the up key there. So you can repeat the commands by hitting up key. And we have root and Docker. So root is the username and Docker is the group name. The next step, what we need to do is we need to add Linux, by the way, to the brand new Docker group. So what we're going to do is use a tool called usermod. And if you see here, there are two key options. There are supplemental groups and append. You don't want to overwrite your existing groups. You just want to add this to the list of groups Linux, by the way, already has. So we're going to run usermod-a for append -big G with Docker for the list of supplementary groups, and then our username, which is Linux, by the way. And there we go. So we added the group here. And if I run groups, you can see that Docker does not appear here. And it's because we didn't relog out and log back in. If you don't want to log out and log back in, you can use the new group command in Docker. And now if you type groups, you will see we have the Docker group. And that means we can also run Docker PS now. And you can see that there's no permissions error. We can see all the containers. And so that sets us up to run our Docker container for the server. The next thing we're going to do is we're going to go ahead and make a Docker Compose file. So our user starts out in their home directory, which is home Linux, by the way, and we'll make a directory here called Minecraft, where we're going to put all of our files. And so I'll change there. What we're going to do here is we're going to create a Docker Compose file that's named dockercompose.yml, which is just short for YAML, which is yet another markup language. It's just a way to make lists and values of things. So we're going to say Docker Compose.yml, and I'm going to go ahead and paste this file in, and you can find this on the links below, so check that out. But this is just a bare bones basic file. So what this is saying is we're using Docker Compose version 3.8. Don't worry about that. The most important part is the image. So this itsg Minecraft server is a fantastic image with tons of docs. I'm about to show you some of that right now. So if you Google the itsg Docker Minecraft server, what you're going to see is there's a GitHub repository. This is super cool because you can see all the source code and the scripts they use to build everything. And it also means that you can hack or change these things as needed. So you can be in full control of your server, and you can add things like mods and all sorts of things in there. And you can see here they have a documentation link, and you don't have to run this just on Docker. You could also run it on things like Kubernetes if you're interested in that. If you click the quick start with Docker Compose, that's basically what we've just done. So I just pasted this in there, and we're going to work off of this. And they have a fantastic documentation site. So you can see all sorts of different tabs up here, from sending commands. If you're using Archon, no problem, it supports that. It's going to tell you about the data directory and how to lay things out. And so you can spend some time on this site and see all the different commands. In this case, the most valuable docs on here to me are definitely the variables. We're going to configure our container with something called environment variables. So we're going to tell Docker Compose, set this key and this value, which is the environment variable, and then what we put inside of it. And the container is going to use those to configure itself on startup. And so there's all sorts of things here, such as whitelist and memory and the message of the day and agreeing to the EULA. All of that will be set up through environment variables. In the file, we also specify TTY is true and stdin open is true. That will allow us to connect to the server once it's started if we needed to get into this server console because our Minecraft client was broken or we needed to debug something. So those are pretty important options. We're going to run this on 25565, which is something you also want to write down with your IP. And so from our local network, we'll connect to this IP with that port. And for your friends, you're going to want to give them your external IP address with that port. So that port is super important. Write that down so folks know. And here's the big part, which is the environment section. So here we're going to say, yes, we agree with the terms. We're going to do things like set memory. And so in this case, I'm going to give this 7 gigabytes. Leave a little bit of room because the system only has 8 gigabytes. So if you set up Minecraft to use the full 8 gigabytes and your system only has 8 gigabytes, you're actually going to run out of memory in some scenarios, and that will kill Minecraft and it'll have to restart and it'll be annoying. So if you're using only 7, Linux can do things like intelligently cache the file system, which is usually one of the slowest parts about a server, and it will make those file reads fast and your Minecraft process won't crash. And we also have our volumes directory, which is data. If you run a Docker container and you don't have a data directory, what will happen is each time you restart, it will forget everything that's ever happened. So if you made a world, you made a cool map, you added your friends, you opt some people, that's all saved in this data directory. And it's super important to keep that safe, but also make sure it's there. Because again, if you run this container without a data directory, every single time, everything's going to disappear. Let's go ahead and set a couple more options here. We're going to say MOTD, which is message of the day. And we're going to say Linux, by the way. And this is just something that your users will see when they're connecting to your server. And then we'll also have a whitelist. And so in this case, one of the problems with Minecraft is that if you make a Minecraft server and you use port forwarding on your router for people to connect, it may not just be your friends. It may be a whole bunch of people. So what you can do is you can find your Minecraft username and put it in the whitelist here, and then only you can connect initially. And when your friends want to connect, you can use Minecraft to allow them to connect, but that will keep all of the weirdos and the internet away from your server. So we're going to go ahead and enter my name there. There we go. And that's the basic configuration for a Minecraft server. So we'll write that out and we'll quit. On Linux, there's also a couple different editors. I use Vi, and if you ever run Vi and can't get out, you can hit escape, and Q. That will get you out. And some people like Nano. So if you've never done this before, just use Nano. Vi tends to work everywhere. I really like it. And I have a video about NeoVim if you're really into it, but it does take a bit of learning. So the next step is we have a Docker Compose file. We have a server in there. We have some environment variables, and now we want to start it up. So what we're going to do is do a Docker Compose up, and we're also going to tell it -D for detach. So that way it's going to run in the background. And what that means is that even if our SSH session dies or we log out, it's going to keep running, which allows us to keep playing. And that's what most players want. So let's go ahead and run that. And what you're going to see now is it's going to be downloading all the layers from the internet. So a Docker container is composed of different layers. So it has a base layer, and then probably adds Java on there. And then it probably adds the Minecraft version, etc. And so that's what it's downloading right now. And so we'll let that download for a second and fast forward. So we're all done downloading, and now we're created. This comes back to that Docker PS command I was showing you. So now if you run the Docker PS, you're going to see, oh, there's our itsg Minecraft server. And that's the container ID. So that's how I reference it. It's been up for 5 seconds. And now you're probably wondering, okay, cool, what's it doing? We can do a Docker logs, and we can take this container ID, and that will tell us. And so in this case, we started up. It's got a data directory. We're type vanilla. We have the 1.20.6 server, and we have a whitelist, which is what we passed in through the environment, so that way only we can connect. And it's going through the startup. And you also notice that that exited immediately. That might not be what you want. So you can do a -F here, and -F will allow it to keep getting all the new log messages. And so some of these will take quite a bit to go on your system. On my system, I have a very fast server with fast internet. And so things seem to go really quick. If it takes longer, that's probably okay also. But we are done and booted up, which means that we can actually test connecting to this now, which is super exciting. Also, just for fun, I decided to run this on my System 76 Linux laptop. So this is just a small 14-inch laptop running Minecraft, running Linux, but it can also run the game. So you don't just have to run your server on Linux, you can also run the client. We're gonna go ahead and click multiplayer here. And you see here's Minecraft server. And if we click edit here, that is a different server. And so we're going to type in our server, which is 196, and click that. And then we'll click play. And there we go. We're joining the world, and we are in. Let's go ahead and add ourselves as an administrator of the server. So what we can do now is we can set this up to say ops in our username, and that will allow us to be an administrator. So we'll do a Docker compose, and then we'll run that. And this gives us all the commands. And what we'll say is we'll say stop, and that will shut down all of our containers. We can also, in this case, remove the data directory, which is rm-rf data, and this will be a totally fresh server again. Make sure if you're running rm-rf, you know it's going to delete the data. Do not run that command. If like somebody on the internet tells you run rm-rf/, don't do that. Don't run that. Only run it on places you mean to, because that means recursively delete all the files in that path. And so we're going to go ahead and run Docker compose up here, and then do a -D again, and that will create a new server. And then we can do a Docker PS, and we can take this container ID and do a Docker logs, and watch that log. And so you can see it's a brand new server again. So it's going to start up and download the version. It's enabled the whitelist, and it's got our server.properties, which is somewhere you can customize and configure your server as needed. An important point too is that we want to get as much configuration as possible in that Docker Compose file, so that if you had a problem, you could recreate your server at any point in time with those exact same settings again. So you could take that Docker Compose file and move it to computers, etc., and it would always come up the same way. The data folder is really important for your actual world data, but for the setup data, we want all of that in Docker Compose where we can. So we'll let this generate a world again and give it about 3 seconds as it goes through that. And now we're up and running. So let's check this out on Minecraft. And we'll go to multiplayer, see our servers up. It also says Linux, by the way, so we configured that in the file, and there's a lot of cool variables like that you can set. And so we'll log in there. And now you can see it's a brand new world. So because we deleted the data directory, that means that all of our world data did not keep going. And so now what we can do is we can type /whitelist, and we can say add, and then you can add your friend's Minecraft username. So this way you can allow other people to connect as you pick and choose, and you can remove them as needed, etc. So I really recommend that approach rather than letting random people connect to your server. We've successfully set up a Minecraft server, and it's actually relatively secure. It runs inside a Docker container, inside a virtual machine, and we only allow people we know to connect. And so that's a pretty robust setup. If you're running the server and you need to run commands, you can SSH into it and run the Docker PS again and get your container ID. And you can run a Docker attached to that container ID. And this will allow you to run commands. So if we do this and hit enter here, you can see the server says unknown command. So if we type say hello, then the server said hello. And now if we switch back to Minecraft, you can see that the server said hello. So any of the server functionality that you want to do, you can do from the SSH console also. So even if you weren't at your Minecraft system and you just wanted to do something or set a configuration or kick a player out, you could do all that just from SSH without even having Minecraft running. So what's next from here? I definitely recommend going to the documentation, which I'll include below, and going through all the different variables and ways you can set this up. You can set up mods from CurseForge and Modrinth and some others. And also there's a lot of different variables you can do here. So you can have your remote console set up. You can do all sorts of things with icons and the max world size. You can set hardcore mode. So this support here is fantastic for the different versions. And if any of this isn't built in, as long as you save that data directory, you can edit the files inside of it. So if you need to do something and you see a tutorial online, which is like edit the server.properties or edit the ops.json, you can edit it. You just have to save all that yourself, because if you made a new Docker container, it would go away. I hope that helps you understand how a Minecraft server is set up. Leave a comment below if you need help, and like and subscribe the video if you want more of these. I'm also putting some links to books down below that you can get, and that really helps the channel, so check those out. But otherwise, I'll see you in the next one. Take care.